What does the Maxwell second law states? It states that the divergence of a magnetic field is equivalent to zero. What does divergence says? We know that divergence tells us if there exists a source or a sink. Source is something which gives out something, whereas a sink is where something enters inside. Source is something that is producing something and giving out something, whereas sink is the place where anything that was produced is entering. Now, what does a divergence of B equivalent to zero tells us? This tells us that there are no sources or sink in case of magnetic field. Suppose we have this magnet and we have this surface S. Then if a magnetic field line is coming out of this place north, then it will go outside and converge here, and inside the magnet it will reach the same place from where it started. It means that if we have a source, we know that if there is a source, then anything that will be produced from the source will go outside, and sink is the place where this thing that is coming out will enter here. A source is not something out of which something comes and gets back into it, right? But in case of magnets, if something comes out of a magnet, it comes back to the same place, because outside the magnet the field lines are like this. They go from north to south, and inside the magnet the field lines go from south to north. Hence we can say that for magnetic field lines there are no sources or sink. Hence we can say that magnetic monopoles do not exist. If there is north pole, then there will be a south pole, and if there is a south pole, there will be a north pole. In case of electric field, we notice that there are sources and sink. A positive charge is a source for the magnetic field, for the electric field, whereas a negative charge is the sink for the electric field. But in case of magnets, north pole or south pole are not separately sources or sink. If a magnetic field line comes out of the magnet like this, then it will come back inside the magnet and reach the same place from where it started. Hence we can say that the divergence of this magnetic field that came out is zero, because it is not acting as a source or a sink, because a sink is something which only takes in things, whereas a source is something which only gives out something. A source does not take in something, but in the case of magnet, this north pole is giving out as well as taking the same thing inside it. Hence the physical significance of the second law of Maxwell is that no sources or sink exists in case of magnetic fields, which means that there is no source that gives out a magnetic field, or there is no sink for a magnetic field. If a magnetic field is coming out of something, then it will come back into that same something. Or we can write it like this, that no monopoles exist, which means that if there's north, then there will be south, right? Because suppose we have this magnet north south, and if we break it, then we get two new magnets. Similarly, if we bake them also, then we will get more magnets. We will not get a separate north or a separate south. This is the physical significance of the second Maxwell's law. Now let's derive this. Now suppose we have this surface, right? And suppose we have put a magnet here, north south. Then we can say that suppose here we are going to find out the magnetic flux. Let's find what is the magnetic flux here. Then we can say that if a magnetic field line is coming out of this place, then it will surely enter this place. It will come back to this thing. Hence we can say that the magnetic flux crossing any closed surface is always zero. Hence flux of magnetic induction B across any closed surface is always zero. When is flux non-zero? Suppose we have this surface and things are only passing from this place, only then the flux is not equal to zero. But if suppose a thing is coming out and entering the same place, then the flux is not zero, right? Hence we can say from this thing that the flux through the surface S, this surface S, the flux is equal to zero. Now let's use divergence theorem and convert this for the whole volume. Now for divergence theorem, we will simply take divergence of this thing. Hence we get volume integral, and the right hand side stays zero. Hence we can remove this integral, and hence we will get divergence of B is equivalent to zero. With this we can derive the Maxwell's second law.